So it's my second attempt at streaming this thing. Actually streamed this thing for like 30 minutes or so, 40 minutes or so. Got stuck, got a call, and just did the rest offline. Anyways, I'm gonna reproduce my solution here. So this is the shortest common subsequence where you have two strings and you're going to return the shortest string that includes both the subsequences. There should always be a valid subsequence or a supersequence if basically you concatenate both strings together, and that should be something that is string 1 and string 2 are subsequences. But if you have something like CAB, AC, and CAB, here you can concatenate something that is like CAB, AC, CAB, AC. The CAB is right there, and the ABAC is right there. So yeah, this is going to be something that you're going to need to use dynamic programming for. And the main insight for this one is if we can do something that is very common dynamic programming, which is finding the longest subsequence of these two strings. The longest subsequence of these two strings is AB. That longest subsequence is common to is basically going to be found somewhere in this thing right here. So whatever letters occur outside of that common subsequence, it doesn't really matter the order. Like if there was a Z in front of the AB here and a C in front of the AB here, the common supersequence, the shortest supersequence could be ZC or CZ, it doesn't really matter, but the AB has to be like after that. So first thing I'm going to do is I'm going to determine the longest common subsequence. Say let get the longest long subsequence, and we'll take the two strings. This will return a string. And let's go ahead and just define two variables for the length. And the common way of solving this dynamic programming style is to create a matrix that is a 2D matrix where each row and column represents like the length of the longest subsequence up to that point, in where that point being, if you imagine the 2D matrix where the row index represents the index within string 1 and the column index represents the index within string 2. The entry within that matrix is the longest common subsequence. It's a numerical value. So I'm going to make this thing, I'm going to treat basically rows as the index in strength 1. So you always do it times the column, so it's going to be times n2. And you want to make it one more than that because like the one index after is the stored value for the next iteration. So that 2D matrix, so that's going to be the rows, and for the number of rows in n1 plus 1. Okay. So iterating through for every row in the range of n1 and for every column in range of n2. And there's different ways you can set this up. I'm going to set it up so that it's like this. So we're going to look backwards. If we are at row 0, if row 0 or column equals 0, so we can't look backwards, then the longest subsequence here is just going to be 0. And else if we are dealing with a spot where the characters match. So the characters match in the previous row and previous column. Then we know that the number of the longest subsequence is one more because this is an extra letter that's in common. So dp of this row column is equal to 1 plus dp of row minus 1 column minus 1. Else we're going to say that this is going to be whatever the most is in common, ignoring or basically skipping over this last index within string 1 or last index within string 2. So it's going to be max of dp of row minus 1 column or minus 1 row column minus 1. Alright, so this gives us a numerical value for a matrix with numerical values for the common characters, and then we need to traverse through that matrix to find the common subsequence. So I'm going to say I have an empty list, and I'm going to traverse it by going backwards through the list, although I could go forward to it as well. Yeah, whatever. Let's say row column is equal to n1 and 2, and then while row 0 and column greater than 0, I'm going to say if dp of row minus 1 column minus 1 is less than, so if on a certain diagonal you find that basically going back one character in both string is the same character, then this should be a common character. String 1 at row minus 1 is equals 1, column minus equals 1. Else if so you want to go backwards through the spots where it maintains the highest. So if there's no single character that matches at that particular index, then you want to go backwards, traverse it where it's still high. So dp of row minus 1 column, if you go backwards on the row index and there's more in common than going back on the column index, then you want to go back on the row index. And since we're going backwards here, we're going to say return common reversed. And just to make sure that this is working, I'm going to go print get long subsequence of string 1, string 2, and return nothing otherwise. Let's see if I okay, AC is a common. This should be AB. That's not good. So I did something wrong here. So if the row -1, column -1 is smaller than append that value, go backwards in both. Else, if you go backwards in your row, and that's longer. Let me go and just print out the DP, make sure everything's looking fine. Okay. Zero, 0, 0, 1, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 1, 2. So it should be traversing two, doesn't really matter, between this 2 versus this 2, I guess. Longest subsequence. So if you're at row 0, is this work. So you're at the last row, last column, where the 2 should be the value. And your adjacent spot would be that's odd. You should be getting the last character of, I'm picking the wrong index for the word. So just double check here. So there's 4 rows and 3 columns. It should match your appending C, but you should be appending B. We do something slightly wrong with my indexing here. It's not going out of bounds. String at row 1. N1 is your rows, N2 is your columns. One plus your row and column. Maximum between row minus 1, column minus 1. Like it feels like it's almost should be a string 2 of row minus 1 here. It should be the same. Should be the same. Your column should be 3. Row, 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 row. Maybe this is not correct. Should it just be something like string 1, row minus 1 is equal to string 2, column minus 1? So yeah, it's not actually it's not based on the subsequence being the letters being different, the amount being different between these exact two. Oh, I know. I think what it was I think it should have been, instead of just less than, it should have been plus 1 is equal to. No, it has to be based on the string. Okay. String 1 of row minus 1 is equal to string 2 column minus 1. Okay, well, so that is the longest common subsequence. And now we're going to use that to construct the answer. So answer is going to be empty array, and we'll have 3 indices, index 1, index 2, and k is equal to 0, 0, 0, while k is less than the length of LCS. So we're going to, we're going to go through all the indices of all the letters within the longest common subsequence and try to add that to the answer. But first we're going to add anything that is not the first letter. So if it starts with AB, then anything that isn't A or isn't A within the string 1 and string 2, we need to add it onto the answer. So while index 1 is less than length of, or less than, I should make these variables be outside of the method. Length of string 1, string 2. Index 1 is less than n1. Answer and let's say letter is equal to the current letter in the LCS. So longest comes subsequence at k, and string 1 at index 1 is not equal to the letter that we're looking for. Answer append whatever letter this is, and increment index 1. Similarly, if index 2 is not the very end and the string at index 2 doesn't correspond to the target letter, answer will append that letter and increment the index. At this point it should be matching, so answer will append the target letter and then increment all indices. At some point, maybe index 1, index 2 might go out of bounds, but that's fine. And then last but not least, if there are remaining letters after the common subsequence has been captured within string 1 or string 2, then we need to capture it. So while index 1 is less than n1, answer.append string 1 at index 1, index 1 plus equals 1, while index 2 is less than n2, answer.append string 2 at index 2, index 2 increment, and then we have the array of characters. We just need to join it. Alright, and that is okay.